Here is your maths teacher Jitendra Bari. Today we are to study chapter number 2 of the mathematics part first, that is real numbers for the class 9. Before starting the real numbers, we have studied the introductory part in the previous standard, that is natural number, whole number, integers, rational number, irrational number, and next to that comes as a real number. So real number is very interesting topic in this chapter. First of all, we will see numbers. Numbers are in the heart of mathematics. About decimal system. Decimal system consists of the base 10 numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We humanly use for the interaction this decimal system. Next is binary number system. This system consists of the two numbers, that is base 2 number 16, zeros and ones. This system is followed by in the computer. The instruction and commands are given through this binary system. By using the decimal system, we will study the following, or we will revise the following numbers. First one is natural number. Counting number we start from 1, 2, 3 and so on are known as natural number, and the set of natural number is given as capital letter N with curly bracket elements of the natural number. We start from 1, 2, 3, 4, 5 and so on. To show the infinite numbers, we should use simply 3 dots, not more than 3 dots, because it has some mathematical meaning. Next to the natural number, that is the next number is whole numbers. Natural number including 0 forms a whole number, and the set of whole numbers is given as capital letter W, which is equal to elements of the whole number into the curly bracket 0, 1, 2, 3, 4, 5 and so on. Again same rule you have to follow. 3 dots for the infinite numbers. Then next comes as an integers. To define integers, we require natural number and whole number. How it will require, we will see. Integer can be defined as whole number with negative natural number. Whole number with negative natural number, and the set is represented by the letter capital I. Negative numbers, negative natural numbers means what? -1, -2, -3 and so on for the infinite number in the negation direction. 0, 1, 2, 3, 4, 5 and so on. Here integer is defined as whole number from 0, 1, 2, 3, 4 and so on, infinite numbers, which is a set of whole number. Whole number with negative natural number. Natural number are 1, 2, 3, 4, but negative means what? In the left direction, -1, -2, -3. Integers can also be defined on the number line 0, 1, 2, 3, 4, 5. In the same way for the left side, negative numbers -1, -2, -3, -4, -5 and so on. The next comes, that is the rational number. definition of rational number is the number which is in the form of p upon q, where p and q are the integers and q not equal to 0. Means what simply, if you have to write the rational number in the form of set, it is denoted by the symbol that is a capital Q. The elements of the rational number will be in the form of set as the number which is in the form of p upon q, that is numerator upon denominator. P is numerator, q is denominator, numerator upon denominator form, or simply we say as p upon q, where p comma q belongs to the integers. Means elements of p and q will be what? Elements of the integer. And condition is that restriction, okay? Q should not equal to 0. Q is a denominator. Q should not equal to 0. If Q equal to 0, if the value of Q equal to 0, that is p upon 0, that is such a number is not defined. So we have given the here restriction that Q should not equal to 0. Then comes as a real numbers. Before starting to the definition of real number, there is another definition of the rational number and in terms of irrational number. Rational number means what? The decimal expansion, the number which is in form of p upon q. If we take the decimal expansion, if it is terminating and or non-terminating recurring, then it is a rational number. If the decimal expansion is non-terminating and non-recurring, then it is a irrational number. It is represented by a capital letter R. Real number is what? Real number is a combination of all the sets. That is, or simply we can say that rational number plus irrational number forms a set of real numbers. In the first chapter we have studied set and subset. If we consider n as a set of natural number, w as a set of whole number, I as a set of integer, q as a set of rational number, and r as a set of real number, then the relation between the all numbers will be natural number is a subset of whole number is a subset of integer is a subset of rational number, and rational number is a subset of real number. So real number is a universal set, or you can say superset of the all such sets. All the elements of these sets are included in the real number. So real number is a combination of rational number and irrational number. Next is order relation of a rational number. Or simply we can say that comparison. For the comparison, we use the three signs. There are three possibilities. If p upon q and r upon s are rational number, such that q, this denominator should be greater than 0, and here yes, it is denominator should be greater than 0. If it is equal to 0, then such number does not exist. So we have restricted here, or the condition is applied and denominator should be greater than 0. What should be the three conditions? First, second, third. First one is what? If p upon q equal to r upon s. Second one, p upon q is greater than r upon s. P upon q is less than r upon s. If we take the cross multiplication, we get p into s equal to r into q. P into s is greater than r into q. Next is p into s is less than r into q. From this relation, we have to define the order of the relation of the rational number. If P into S equal to R into Q, then P upon Q is equal to R upon S. This is the first relation. Second one is, if P into S is greater than R into Q, then we get P upon Q is greater than R into S. Same way, if P into S is less than R into Q, we get then P upon Q is less than R upon S, or simply vice versa. If in this condition, this is a vice versa. If P upon Q equal to R upon S, then we get P into S equal to R into Q. Or in the reverse direction, or conversely, if an unleaf part, if P into S equal to R into Q, then P upon Q equal to R into S is applicable for all these three conditions. Next is properties of rational number. If A, B, C are rational numbers, then we have to satisfy the following properties. Here is property addition, multiplication. Properties we have to write. This is commutative property. Second is associative. Third one is additive. Fourth one is inverse. These are the four properties which rational number satisfies. We know there are four operations in mathematics, which are addition, subtraction, division and multiplication. For subtraction and division, the rational number does not satisfy the following properties. It only satisfies for the addition and multiplication. So we have taken for the addition and multiplication, for which the rational number satisfies the following properties. Now first of all, what is meant by commutative property? If A, B, C are the three rational numbers, then we have to consider first for commutative property. What is commutative property? If the addition of the two rational numbers, that is A plus B, then that is equal to the B plus A. How to read this property? Commutative property with respect to addition. Now commutative property with respect to multiplication also satisfies. A multiplied by B, which is equal to B multiplied by A. For example, if we take A equal to 1 upon 2, B equal to 3 upon 7. We have to satisfy, is this a property satisfies or not? We have to see. What is the value of A? A equal to 1 upon 2. Plus what is the value of B? That is 3 upon 7. Now take the addition of these two rational numbers. That is simply, first of all, take the LCM. 3 plus 7, 3 upon 7 plus 1 upon 2. Therefore, cross multiply. 1 into 7 plus 3 into 2 upon 2 into 7, which should be equal to what? This side RHS. 3 into 2 plus 1 into 7 on 7 multiplied by 2. Now what is multiplication of these two numbers? 1 into 7, 7 plus 3 into 2, 6 on 14, which should be equal to 3 to 6 plus 7 upon 14. 7 plus 6, 13. 13 upon 14 equal to 13 upon 14. Both the LHS and RHS are equal. Means this property is satisfied for addition. Same way for the multiplication also we will see. We have considered A equal to 1 upon 2, B equal to 3 upon 6, 3 upon 7. Same for the we have to satisfy commutative property with respect to multiplication. 1 upon 2 multiplied by 3 upon 7, which is equal to 3 upon 7 multiplication of multiplied by 1 upon 2. If the multiplication is there, multiplication of two rational numbers, what we have to do? Numerator will multiply to the numerator, denominator will multiply to the denominator. 1 into 3 upon 2 into 7, which is equal to 3 into 1 upon 7 into 2. 3 upon 14, which is equal to 3 upon 14. For multiplication also it satisfied. Then next is associative property. What does the associative property says? It requires three numbers. A, B, C are the three rational numbers. Then A plus B bracket close plus C, which is equal to A plus into bracket B plus C. Same thing for the addition we have taken. Now we will take for the multiplication. A multiplied by B multiplied by C, which is equal to A multiplied by into bracket B multiplied by C. Now what is identity? Additive identity. Then what such number we, if we add to the A, we get answer as a A, that is simply 0. A plus 0 is equal to 0 plus A, which is equal to simply A. If 0 is added to the A, we get the same number as a A, that is the additive identity. In the same way for the multiplication. Multiplicative identity is what number if we multiply to the given number A, that we get such that we get the number A, that is A is multiplied to 1 such that we get A. So we can take as 1 into B, that is equal to A. Then inverse, additive inverse. Now what is inverse? Inverse means what? Opposite. If we take the rational number A, what number we have to add so that we get the answer 0, that is A plus or minus A, that is equal to A minus A, which is equal to 0. If we subtract A from the given number A, we get 0. That is the additive inverse property. Same way for the multiplicative inverse is what? If you take the rational number as a A, then what such number we will multiply so that we will get as a 1. Inverse of A, multiplicative inverse, that is equal to, here A we get answer, we get here answer as a 1. So this property can be written as commutative property with respect to addition, commutative property with respect to multiplication, associative property with respect to addition, associative property with respect to multiplication, additive identity and multiplicative identity, additive inverse and multiplicative inverse. In such way, these following properties are satisfied by the rational number. We have taken for addition and multiplication. For subtraction and division, the rational number does not satisfy the following properties. And next is decimal form of any rational number is either of the type terminating and non-terminating recurring. For that we will take one example. Two upon five is a number in the form of p upon q. That is it is a rational number. Now we have to take it decimal form. So first of all, numerator, the number on the numerator is what? Dividend, and the number at the denominator is divisor. Now you have to do the usual division. The condition of the division is what? Dividend should be greater than the divisor. Here it is opposite. So what we can take? Follow the rules of the division. Take 0. Then what we do here? On the question we give here as a decimal point. Now 5 comes in the table of 20 and the fourth level, that is 5 for the 20. If we subtract 20 from the 20, we get the remainder 0. That is, if the remainder is 0, then quotient is 0.4. That is, if we divide 2 by 5, we get quotient as 0.4. It is a terminating. The remainder is 0, then the quotient gets stopped. It does not extend some more values. It stops here. For non-terminating, recurring another word is what? Repeating. Next example 40, 17. Take 1 0. 36 1 36 to the 72. If we subtract 72 from the 80, we get the remainder as a 8. Again take 0. Here 8 is recurring again and again. Means remainder is same 8. So the quotient will be again 2 2 2. So if we divide 17 by 36, we get the quotient as a 0.47222. That is, simply we can add 0.472, and above to the 2 we get here is a dot. Here 2 is repeated again and again. So we have given here dot to the head of the 2. If the remainder is not equal to 0, then we can say that non-terminating. If remainder is not equal to 0 and in quotient the same number of digits is repeating again and again, we say that the rational number is of the form non-terminating recurring. If the if the remainder becomes 0, quotient is terminating. So the rational number of the form terminating. So this becomes the definition of the rational number. As a rational number is again the decimal expansion of a rational number is either of the form terminating or non-terminating recurring. To express the recurring decimal in the p upon q form, means recurring decimal is given, you have to convert it into p upon q form. First one, with example we will see 0.777. In same number is recurring again and again. That is 7 is recurring again and again. We can say that 0.7. At the end we have to give dot. If the single number is repeating again and again, so we have to give dot. If the two number is recurring, for example 0.121212, so we can give 0.12 bar to the 2 digit after the decimal number. How we can read to the given number 0.1212. This is a rule to read the number after the decimal point. Then next is this part we have to see into 3 questions. this question 7.529529 three digits are recurring, so we can write it as bar 7.529 and 529 bar. First of all, how to solve such questions? Same number of digits is recurring. So let assume it as let x is equal to 0.777 or something 0.7 dot multiply, say it as equation 1. The next step is multiply both sides by 10. If same number of digits is multiplied, one digit is multiplied, we have to multiply it by the 10. If two digits are recurring, so we have to multiply it by 100. If three digits are recurring after the decimal point, we have to multiply by 1000. This 10 is equal to, if we multiply the given number 0.777 by 10, we get 7.777. To the equation as 2. Now we have to subtract equation 1 from the equation 2. That is 10x minus x, that is equal to 7.777 minus 0.777. We get here 10x minus x, that is 9x is equal to 7. Therefore x is equal to 7/9. The decimal expansion of 7/9 is 0.777. Same for this example. Let assume it as x. Let x equal to 0.121212. That is equal to 0.12 bar. Here two numbers are repeating after the decimal point. So in this case, you have to multiply it by 100. Both sides now multiply both sides it by 100. Therefore 100 times x is equal to, if you multiply it by 100, then this decimal digit will shift after the two numbers, that is 12.121212. Same as equation 1, equation 2. Now subtract equation 1 from the equation 2. What we get? 100x, that is equal to what? 99x, which is equal to 12. Therefore value of x is what? 12 divided by 90. Same way for the third. Here 529 is repeated, so we have to multiply the given number by 1000. First of all, let assume x is equal to 7.529529 dot equal to 7.529 bar. It is same as 7.529 bar. Now multiply both sides by 1000. 1000 times x is equal to, this decimal point will shift after, if we are multiplying by 100,000, so the decimal point will shift after 3 digits to the right. 1, 2, 3, that is 7529.529 and so on. This is equation 2, this is equation first. Again, as per the rule, subtract equation first from the equation second. 1000x minus x, that is equal to 7529.529 bar minus 7.529 bar. Therefore 999x equal to, this decimal point will be subtracted, that is it will be as 7529 minus 7, because after the decimal digit there are the same number, so the same number are there, so subtraction of the same numbers after the decimal digit, it become 0. That is simply we get 999x equal to 7. This is what? X is the rational number. 7527 upon